My name is Ifat Afek. I'm a system architect at Nokia and the PTL of the Vitrage project. And I'm going to talk about the project updates of Pike release and Queen in Vitrage. So just a very brief overview of Vitrage in case someone is not familiar with it. Vitrage is an official OpenStack project for root cause analysis. In case there is a failure in the system, a lot of resources could be affected, and the cloud operator might see a long list of alarms, and it might be hard to understand what exactly went wrong. And Vitrage can help by detecting the root cause and showing it clearly in the UI. And on the other direction, sometimes not all resources are monitored properly, and Vitrage will raise additional alarms on resources that are affected by the failure, and thus provide a complete and holistic view of the status of the system. Some background about the project. Vitrage was started 2 years ago. It became an official project 6 months later. The first official version was Newton, and in the last release cycle we had about 10 active contributors. I'll go briefly over the architecture because it's a background for the next slides. So Vitrage collects information from data sources that are built in a pluggable model. We get information from OpenStack components, Nova, Cinder, Neutron, Heat, AODH, and also from external monitors. We currently support Nagios, Zabbix, CollectD. And all this information is retrieved into Vitrage either by polling or by push notifications, depending on the data source. Most of them are using notifications, and the information is inserted to a topology graph. And the topology graph has all the resources from the physical layer, the virtual layer, the application layer, and you can see the relations between the layers and the effect they have on one another. Whenever the graph is modified, Vitrage evaluator takes action, and the evaluator is responsible for the business logic. The evaluator loads the Vitrage templates, which are YAML files, human-readable files that are very easy to understand and to edit. And the information in the templates consists of conditions and actions. So if something, there is a condition, a topological condition, for example, a nick is down and the nick is attached to a host, then the action to be taken is to modify the state of the host to error and to raise an alarm on the host. So the evaluator is responsible for evaluating the templates and taking the actions. Vitrage notifier is responsible for notifying external systems when there are alarms or state changes. Currently, we notify Nova when the host is down. In many cases, Nova is not aware of the failure, if it's a network failure. We execute Mistral workflows when it's determined in the templates. And we also have an option to send SNMP notifications on alarms that were raised by Vitrage. We have a machine learning module, which I'll describe in the next slides. And there is an API layer, a command line interface, and a UI as part of the Horizon dashboard. I'll describe the main features that we worked on during Pike. So I think the most important feature was the integration between Vitrage and Mistral. Mistral is an OpenStack project for workflows. You can create workflows with different tasks and conditions and all kinds of workflows. And while Vitrage is only meant to provide insights. And together, Vitrage and Mistral are capable of both doing the analysis part and executing the corrective actions. So it's a very powerful combination. For example, Zabbix detects a nick failure, that the nick is down. Vitrage understands that if the NIC is down, then the host is down and the VMs are down. And in this case, Vitrage asks Mistral to execute a workflow for VM migration. And this should be a workflow because VM migration is done asynchronously. And Mistral workflow will ask Nova to do the VM migration and will then follow up the progress, make sure it was completed successfully. So Mistral sends Nova a request to migrate the VM. As soon as Nova is done with the migration, it notifies Vitrage that the VM was migrated to a different host. And Vitrage deduces that the VM is no longer affected by the NIC failure, so the alarm on the VM is cleared. Okay, machine learning. In Pike, we have made the preliminary steps towards a machine learning solution. So currently, the business logic is determined by Vitrage templates. So the cloud operator should create the templates based on his experience. We would ideally want a machine learning process to suggest new templates based on the history. So in case there is a root cause effect that is determined by an algorithm, it will suggest new templates to be used automatically. We have made the first steps. It means we have created an infrastructure for running machine learning algorithms. And with the help of Bell Labs, we wrote the first algorithm, which is very basic. It finds correlations between alarms. So looking on the past alarms, it can detect that most of the times 2 alarms appear on the same time, more or less, and find a correlation. But it doesn't find the causation. So if one alarm always appears first, it doesn't mean that this is the root cause. It may mean that it is more monitored by a different monitor or more frequently. So identifying the root cause is more complex, and this should be addressed by future algorithms. Other features that we implemented in Pike: we enhanced the Vitrage template language. We added an option for adding not in the condition if something happened and not something else. We, like I said, support SNMP notifications to externally. We added key clock support as a possible alternative to Keystone. So in case Vitrage is used in a non-OpenStack environment. Vitrage is a general engine. It does not care if it gets input from OpenStack or from whatever other environment. And we added support for alarm equivalence in case the same alarm is both created by Vitrage and by external monitor, and I'll talk a bit about it later. Regarding Queen's features, first, I didn't mention it on the first slide. There was a link to, we had a virtual PTG last month where we discussed the plans for Queens. There is an Etherpad, and the link appears on the first page. The main project we are currently working on is refactoring the high availability solution of Vitrage and supporting alarm history. So these are 2 different topics, but we have made a common design that solves both of them. So when we are working on them, we are actually progressing with both topics. And we already started it. We did the design in Pike. In Pike, we also created, we separated the Vitrage graph into 2 different processes. One is the Vitrage collector, which is responsible only for collecting data from the data sources. And the other is the Vitrage graph, which is responsible for the processing of the information and for the evaluating it. In Queens, currently, we are working on persistence. We introduced a MariaDB database to Vitrage. Until now, all of the information was in memory. We are using the NetworkX in-memory graph database. But now we are going to store all the events that arrive to Vitrage. We will store them in MariaDB. And in addition, periodically we will store snapshots of the entire graph. So if the Vitrage graph is down, a new process can be raised, load the latest snapshot, and do a playback of all the events that happened since the latest snapshot. And it should happen very quickly, more than today. And the next phase is to really support alarm history, because storing the history is not enough. In order to show it to the user, we should do two things. One is to have a copy of the graph. I mean, we have the current graph that keeps getting updated, and we need to have a graph, a different graph for, like, say, last week. If you would like to see what was the state of the graph last week and what was the root cause, we will construct a different graph for that. And of course, we need UI for it. And ideally, we would like a cool UI with a slider so you can slide back in time and see the graph changes. But it's very complicated to implement. I'm not talking about the UI itself. I'm talking logically, because the graph keeps changing, and you want to have like a consistent view, more or less. And I believe this will happen in Rocky and not in Queens. Another important topic we are working on is configurable notifications. At the moment, Vitrage Notifier calls either Nova or sends SNMP notifications or calls Mistral API. But we need an API that allows any consumer to register to Vitrage alarms based on the alarm type, based on the resource ID, or based on a regular expression, and get callbacks to a specified URL. So this is already in progress. I'm going to talk about, there is a very big topic that we are in the middle of its design. It's not finalized yet. There is a spec that is under review. And it's resource equivalence. So it could happen that two data sources actually report the same resource. And it could be that they report slightly different properties. Thinking about it, we would like to merge the information. But merging is problematic, because we might not know which one to trust more if there is a conflict between them. And also, if one of the data sources later on decides to no longer report the resource, we need to be able to restore the information from the from the other data source. So instead of merging, we have decided to keep both and add an equivalence edge that represents the fact that both are equivalent. But thinking about the user, the end user will not understand it. So we are thinking about ways to aggregate the information. Maybe have an API, the API layer returns some abstraction of a semi-vertex that is a merge of the two vertices that really exist in the backend. And like I said, it's under design. Another issue that is still under design, it's called the proactive root cause analysis. So until today, it was quite straightforward. If the host is down, we deduce that the instance is down. And now we are talking about a different use case, that we get a monitor alarm that the instance is down, and we did not get an alarm that the host is down, maybe because the host is not down, or maybe because the monitor is taking more time to report it. So we would like to add an alarm, a suspect alarm, that the host is down, and then run maybe a health check to see if really this is the case. And then maybe mark the alarm as verified or remove it, or this is still not clear how exactly we are going to handle it, but the use case, I think, is clear. How to handle the fact that we are missing some alarms, and it could be because of a technical issue with the monitor, and we need these alarms in Vitrage. Other features in Queens. We have made performance enhancements for parallel evaluation. So there is one restriction that when events arrive to Vitrage, they must be processed by the order that they arrive. we cannot take the event queue and parallel it, run it in parallel, because it will mess things up. But once we process an event, we need to evaluate all relevant templates and see if some actions should be taken. And the template evaluation can be made in parallel. Even if two templates are related somehow to one another, then we have a mechanism for overlapping templates. We know how to handle this case. So we introduced the option to evaluate the templates in parallel. It's already merged, and now we are testing it. The next topic is integration with OPNFV Doctor project. This has been discussed for a long time now. Vitrage complies with the requirements of OPNFV Doctor, but technically we need to add Vitrage to the Apex installer by OPNFV. And this, I hope, it will get started soon. And we also need to add Vitrage to the test suite of OPNFV Doctor. SNMP parsing service. So I mentioned that we send SNMP notifications. And now we are going to add a service that gets SNMP traps from external systems and creates events that can be later on processed by Vitrage data sources. So it's like having an SNMP data source for Vitrage. Template squad, we would like to have an API for easier adding and removing templates. Currently, the templates are on the file system. We are going to put them in the database and have an API for managing it. And maybe have like a discovery agent for the network topology or for the host or something like this. And that's it for Queens. If you have other ideas, would like to contribute or suggest some blueprints, some things that you think is missing, we are very happy to hear new ideas. And if you have questions. OK, thank you.
So I have a question.
Yeah.
Most of the problems arise sometime the checks which you mentioned, Nagios or something like that. Those checks will not be able to identify. Like for example, the timeout. Sometimes there's a timeout error happens because some may take a longer time to go through this and sometimes ready to change. So how do you? I don't think any kind of checks will be identified.
I'm not sure. What was the last sentence? So you talked about the time?
Yeah. So I'm saying that the checks, many of the complex issues cannot be even covered by the checks.
Because it takes too much time?
No, sometimes we don't have the checks for that.
Yeah.
For example, so the checks are for the errors which are very consistent message, consistent failure scenario. Like for example, if there is one API is failing, it's failing because there is one dependency API is having timeout issues, not because this API is having.
Yeah.
So how do we analyze this?
So Vitrage is not a monitor. I mean, when you have your monitor, you need to configure it to monitor the correct things. Sometimes it's not trivial, like you said. But Vitrage only can correlate alarms that it gets from external monitors. I mean, we are about correlation, not about monitoring. Monitoring is a very complex issue. Any other question? OK, thank you.